1,500 kilometers on a single charge. Not a concept. Not a promise from a startup with a fancy logo and 0 cars on the road. A real announcement from a real company with $1.4 billion and over 1,200 engineers behind it. To put that number in perspective, that is driving from Los Angeles all the way past Salt Lake City and still having range left over. That is Beijing to Shanghai in one shot, no stopping, no waiting, no charging. That is more than double what the best electric cars on the road today can do. And before you assume this is the kind of number that gets quietly walked back 6 months later, consider this. The company behind it has been building cars for nearly 30 years, exports to over 130 countries, and has never once needed a bailout or a government rescue to stay alive. Their name is Chery. And before you scroll past thinking this is just another bold claim from a company nobody will remember next year, stick with me. If you find this kind of story fascinating, hit the like button and subscribe so you never miss one. Because the story behind this battery, the science, the people, and what it means for every single person who drives a car is something you are going to want to know. We are going to go back 30 years to a leaky brick factory, walk through the wall that every electric car keeps hitting, and then land on an announcement that made the entire battery industry stop and pay attention. We are also going to look at why this is bigger than one car company, bigger than one country, and bigger than the auto industry itself. By the end of this video, the words range anxiety are going to mean something very different to you. Let's start at the very beginning. 8 engineers and a leaky roof. The year is 1996. A man named Yin Tongyao has just walked away from one of the most secure jobs in China. He was working at FAW, the biggest car company in the country at the time. Steady paycheck, respected position, good benefits, the kind of job most people spend their whole careers chasing and never want to give up. He quit anyway. He packed up, took about $30,000 in seed money, gathered 8 engineers, and moved into an abandoned brick factory on the edge of a small city called Wuhu. Wuhu is in Anhui province, a region most people on China's wealthy coast had barely heard of at the time. The factory had no proper heating, no air conditioning. When it rained, the roof leaked. There were no fancy meeting rooms or glass offices. The early planning sessions, the ones where they mapped out what kind of car company they wanted to build, happened in what people inside Chery still call the small grass hut. 8 people, 1 dream, and a building that most rational adults would have taken one look at and walked straight back out of. They called themselves the 8 Immortals, and they got to work. Their very first move was pragmatic and clever. They bought a used engine production line from an old Ford factory in Dagenham, England. They shipped it back, installed it, and bolted together a chassis based on an existing design. It was not glamorous engineering, it was survival engineering. Get something built, get something running, prove it is possible. And in December of 1999, the first Chery rolled off the assembly line. A car called the Fengyan. It was not a head-turner, it was not loaded with technology. But it ran. It was real. And it was theirs. From that point, the progress was relentless. By 2006, just 7 years after that first car, Chery had designed and built their own engine completely from scratch. No borrowed designs, no copied parts, their own engineers, their own blueprints, their own result. That is not a small thing. Designing an engine from the ground up is something that takes most established automakers decades of accumulated knowledge. Chery did it in less than a decade, starting from a leaky brick factory. By 2025, the numbers were staggering. 2.8 million vehicles sold globally in a single year, operations in more than 130 countries, over 18 million customers worldwide, a spot on the Fortune Global 500 list at number 385, and the title of China's #1 passenger car exporter held for over 20 consecutive years. From 8 people in a grass hut to one of the most powerful car companies on Earth. That arc matters because it tells you who you are dealing with. This is not a company that chases headlines. This is a company that executes. And the problem they decided to take on next has been quietly undermining the electric vehicle revolution for years. The wall every electric car keeps hitting. Electric cars today run on lithium-ion batteries, the same basic chemistry that powers your phone, your laptop, and your wireless headphones, just packaged at a much larger scale. And when electric cars started going mainstream, the marketing around this technology was genuinely exciting. Clean energy, instant acceleration, no more gas stations. The future had arrived. Then people started actually living with these cars, and the gap between the marketing and the reality became hard to ignore. The real-world range on most electric vehicles today sits somewhere between 250 and 300 miles under normal conditions. For daily commuting, that is perfectly fine. Most people do not drive more than 40 or 50 miles a day, so the math works out easily. But the moment you plan something longer, a road trip, a visit to family a few states away, a drive through a region where charging stations are sparse, the experience changes completely. You are no longer just planning a route. You are planning around charging stops. You are checking apps to see which stations are working, which ones are occupied, and how long the wait might be. You are budgeting 30 to 45 minutes minimum at each stop, sometimes longer if the station is busy or if the battery needs a full top-up. What should be a 5-hour drive becomes a 7-hour exercise in logistics. And if anything goes wrong, if a charger is broken or the queue is long, you are sitting in a parking lot doing math. But the charging inconvenience is only part of the problem. The bigger issue is the cold. Lithium-ion batteries and low temperatures have a relationship that nobody in the electric vehicle industry likes to talk about loudly. At around 36 degrees Fahrenheit, which is just barely above freezing, a lithium-ion battery can accept 36% less power than it does at a comfortable room temperature. That number comes from research at the Idaho National Laboratory, not from critics of electric cars, but from scientists studying the actual chemistry. What that means in practice is this. In freezing conditions, your range drops by 20 to 30% before you have even left the driveway. Your charging slows down significantly. In really cold weather, charging times can double or even triple. And the colder it gets, the worse it becomes. There is a reason that every January, without fail, headlines appear about electric car owners stranded on highways in the snow, their batteries depleted faster than expected, their charging options limited by weather and infrastructure. And even in mild weather, there is a slow decline happening that most owners do not notice until it becomes impossible to ignore. Every single charge cycle wears the battery down a little bit. The chemical reactions that store and release energy are not perfectly reversible. Over time, capacity fades. The pack that once gave you 280 miles now gives you 250, then 220, then 200. You cannot stop it. You can slow it, but you cannot stop it. It is just how the chemistry works. Layer on top of all of this a power grid that was never designed to handle millions of cars charging simultaneously every evening, and you begin to understand why electric vehicle adoption has hit a ceiling that government incentives alone cannot break through. The technology works, but it has real limits. Structural, chemical limits that cannot be patched with a software update. That gap between what electric cars promise and what they actually deliver in the real world is exactly what Chery set out to close. And what they announced on one night in March of 2026 did not just close the gap, it redrew the entire map. Battery Night, the announcement that changed everything. March 18th, 2026. Wuhu, China. Chery held an event they called Battery Night. No celebrity hosts, no theatrical light shows. Just engineers, investors, and an audience of industry professionals who knew exactly what they were there to hear. The event was technical and specific, and the numbers Chery put on the screen that night landed like a thunderclap. They unveiled what they are calling the Rhino S, an all-solid-state battery. To understand why that matters, you need to understand one key difference between what exists today and what Chery is proposing. Every lithium-ion battery currently powering electric vehicles uses a liquid in the middle. That liquid, called an electrolyte, is what allows electrical charge to move between the two ends of the battery. It works, but it comes with serious limitations. It does not perform well in extreme temperatures. It carries safety risks if the battery is punctured or damaged. And it puts a ceiling on how much energy you can pack into a given amount of space and weight. A solid-state battery removes that liquid entirely. Instead of a liquid electrolyte in the middle, it uses a solid material. Think of it like replacing a water pipe with a steel rod. More stable under pressure, more efficient at doing its job, and capable of things the old design simply cannot achieve. Chery's Rhino S packs 600 watt-hours of energy per kilogram of battery weight. To give that number some context, a Tesla battery pack today sits at around 250 watt-hours per kilogram. Chery just fit more than 2.5 times the energy into the same amount of space and weight. That is not an incremental improvement. That is a generational leap. The result is 1,500 kilometers of range on a single charge. 930 miles. Beijing to Shanghai without a stop. Los Angeles to the Utah state line with room to spare, in one shot, with no charging break. But the number that truly set the room on fire was not the range figure. It was the temperature claim. Chery says the Rhino S delivers that full 1,500 kilometers at negative 30 degrees Celsius, negative 22 degrees Fahrenheit. That is the temperature where your smartphone shuts itself off to protect its own battery. That is colder than a typical winter in Chicago, colder than most of Canada in January, colder than nearly anywhere in Europe gets. And Chery says their battery performs at full capacity in those conditions without any meaningful drop. If that holds up under independent real-world testing, it is not just an improvement on existing technology. It is an entirely different category. A battery that works everywhere, for everyone, no matter what the thermometer says outside. Alongside the Rhino S, Chery announced a second system called the Rhino Liquid Battery. This one keeps the liquid electrolyte but pushes the chemistry to its absolute limit. Peak charging power of 1,200 kilowatts. For comparison, the fastest chargers most people have ever encountered at highway rest stops deliver somewhere between 150 and 350 kilowatts on a good day. Chery's system delivers more than 3 times that at peak. The practical result, plug in for 8 minutes and you gain 500 kilometers of range. Around 310 miles. That is roughly the time it takes to walk into a rest stop, order a coffee, and walk back to your car. And the battery is rated for 5,000 full charge cycles, which, if you charged from 0 to 100% every single day, works out to almost 14 years before it even reaches the end of its rated life. Most people trade their car in long before that. Chery's vice president, Guan Shan, stood in front of that room and told the audience plainly that there is no budget cap on making this happen. Whatever it costs to bring this to mass production, they will spend it. Building a battery in a lab is one thing. Building millions of them at a price ordinary people can afford is something else entirely. But here is where the story gets significantly bigger, because Chery is not doing this alone. The global race nobody is talking about. Solid-state batteries are not Chery's idea alone. The concept has been explored in research labs for decades. What is new is how many serious, well-funded, world-class organizations are all converging on the same finish line at the same time, and how quickly that finish line is approaching. Toyota is arguably the company that has spent the most time and money on solid-state technology of anyone outside of a pure battery company. They hold over 1,000 patents in this space. Not applications, not filings still under review, but granted patents. They have been working on this for so long that their engineers know where every dead end is. They are targeting small-scale production by 2027. UNVEILED, currently the largest electric vehicle company on the planet by sales volume, is on the same 2027 timeline with their next generation of battery technology. CATL, the world's single largest battery manufacturer, a company that supplies batteries to Volkswagen, BMW, Tesla, and dozens of other automakers, is also targeting 2027. Samsung ST in South Korea has moved beyond research and is already running a physical pilot production line. BMW, Volkswagen, and Mercedes-Benz each have their own solid-state programs progressing through various stages of development. The Chinese government, recognizing what is at stake, has invested approximately $830 million into 6 different solid-state battery companies to ensure this technology reaches mass production on Chinese soil. Chery alone is backed by $1.4 billion and a research and development team of over 1,200 specialists. Step back and look at this picture as a whole. Toyota, UNVEILED, CATL, Samsung, 3 of the biggest European automakers, the Chinese government, and Chery, a company born in a leaky brick factory now sitting at the same table as all of them. Every single one of these organizations is pointing at the same target. This is not one company chasing a wild idea. This is an entire global industry simultaneously deciding that the next era of energy storage has arrived and racing to be the one that delivers it first. And Chery is not waiting for the rest of the infrastructure to catch up. They are already building it themselves. Their charging network, called Zunlong, starts with 100 stations across 10 cities. From there, they are scaling to over 20,000 charging stations by 2029. These are not basic plug-in points. They are built with vehicle-to-grid capability, meaning your car can push electricity back into the grid during peak demand hours, turning every parked vehicle into a small distributed power source. The system is designed to operate at 96.5% efficiency, significantly better than most charging infrastructure running today. 20,000 stations by 2029. Built from scratch by a car company. That is the kind of vertical commitment that signals this is not a product launch. It is a platform. And the further you zoom out, the clearer it becomes that this is about something much larger than cars. Bigger than the car in your driveway. Here is the thing that most coverage of this announcement misses completely. A battery that stores 600 watt-hours per kilogram, works at -30 degrees Celsius, charges in minutes, and lasts for thousands of cycles does not just change personal transportation. It changes the entire energy equation. Start with freight. Long-haul trucking is one of the most stubborn problems in the global effort to move away from fossil fuels. The batteries needed to power a heavy truck across 1,000 miles of highway have always been too large, too heavy, too slow to charge, and too unreliable in cold weather to be practical at scale. The economics never worked. A solid-state battery at the energy density Chery is claiming does not just improve those numbers. It changes the fundamental math of whether electric freight is viable at all. Move to public transit. Cities around the world are trying to electrify their bus fleets, but keep running into the same operational problems. Buses run long routes, all day, in all weather. They cannot afford a 40-minute charging break in the middle of a schedule. An 8-minute charge that delivers 300 miles of range changes the entire operating model for every transit agency on Earth. Think about energy storage for buildings. Solar panels are now cheap and widely installed, but storing that solar energy overnight for use when the sun is not shining still requires large, expensive battery systems. Higher energy density and longer cycle life make solar storage dramatically more practical for individual homes, commercial buildings, and entire city blocks. And then consider the parts of the world that most of these conversations never include. Chery already sells vehicles in over 130 countries. A significant portion of those markets are places where the electrical grid is unreliable or non-existent, where the nearest gas station can be hours away, and where energy access directly determines quality of life. A vehicle with 1,500 kilometers of range and a battery that performs in extreme conditions is not a luxury product for those communities. It is infrastructure. It is the difference between being connected to the modern world and being cut off from it. The battery is not a car component. It is the central piece of how the world stores and moves energy over the next 2 decades. And whoever cracks it at scale, whoever can manufacture it reliably, consistently, and at a price that reaches ordinary people, does not just lead the automotive market. They shape the foundation of the global energy system for a generation. Right now, a company that started with 8 people and a grass hut is one of the leading contenders for that position. They built their own engine when nobody believed they could. They became the top car exporter in China while most of the Western auto industry was not paying attention. They grew to 18 million customers across 130 countries without ever becoming a household name in Europe or North America. And then they walked onto a stage in Wuhu and put 1,500 kilometers on the board. The rest of the industry is not laughing. They are watching very carefully, and the window for dismissing Chery as a minor player quietly closed a long time ago. What comes next? To be straightforward about where things stand, Battery Night was an announcement. The Rhino S is not sitting in a showroom today. Solid-state batteries at this scale have never been mass-produced by anyone on Earth. The jump from a working prototype in a controlled lab environment to millions of units rolling off an assembly line at competitive cost is genuinely difficult, and every company in this race is still working through it. That honesty matters. But the trajectory is clear, and the timeline is closer than most people realize. 2027 is the stated target for Toyota, BYD, and CATL. That means within the next 12 to 18 months, we will very likely see the first solid-state batteries moving from controlled lab settings into limited, real-world production environments. Within 3 to 5 years after that, if the timelines hold and the manufacturing challenges get solved, these batteries will start appearing in vehicles that ordinary people can actually buy. When that happens, the entire conversation around electric cars shifts, not incrementally, fundamentally. No more planning a road trip around charging stops. No more 30-minute waits at a supercharger in the middle of a highway. No more watching your estimated range shrink in real time because the temperature dropped overnight. No more making the uncomfortable calculation that a gas car just fits your life better, because the electric option cannot get you where you need to go without a complicated charging detour. 1,500 kilometers on a single charge. 8 minutes for 500 more kilometers when you need it. Full performance at negative 30 degrees Celsius. A battery that outlasts the car itself. That is the target. That is what Chery put on the board in front of the entire industry on March 18th, 2026. And with $1.4 billion committed, 1,200 engineers working on it, a charging network already under construction across 10 cities, and every major player in the global battery industry racing toward the same finish line, the question has stopped being whether this technology arrives. The only question left is how soon it lands in your driveway. A company that once held planning meetings in a grass hut just sent a signal that echoed across the entire automotive world. And the entire automotive world heard it loud and clear. If this video gave you something to think about, hit the like button and subscribe so you do not miss what comes next as these batteries move from announcements to actual roads. There is a lot more of this story still to tell, and I want to hear from you. If a car could genuinely take you 900 miles on a single charge and top back up in the time it takes to grab a coffee, would that finally convince you to go electric? Drop your answer in the comments below.